In the endless darkness between the stars, something moves. A rogue world, torn from its home, drifting through the void, hungry, invisible, unstoppable, and it devours everything in its path. Imagine absolute darkness, not the night on Earth, where the sky is studded with stars, but true cosmic emptiness, the space between galaxies, where light dies before it can be born. And there, in this abyss, something rushes. An object without a name, without a home, without destiny. A rogue planet. A lone wanderer, ejected by a gravitational catapult from its home system billions of years ago, and since then hurtling through the void at a speed our minds can barely comprehend. It doesn't reflect starlight. It doesn't radiate heat. It simply exists cold, dead, invisible. And it is hungry. In 2025, astronomers detected something incredible. A gravitational anomaly, 600 light-years from the Sun. At first, it seemed like an instrument error or another calculation glitch, but the data repeated again and again. Something massive was warping space-time, like an invisible giant's hand crumpling the fabric of reality. When scientists finally gathered enough information, the picture turned out to be simultaneously mesmerizing and terrifying. It was a planet, but not an ordinary planet orbiting a star in a cozy orbital cradle. This was a cosmic monster. The rogue planet is approximately 10 times larger than Jupiter. Think about that number. Jupiter is a gas giant that could fit 1,300 Earths inside it. Now multiply that by 10. The mass of this object is so monstrous that its gravity begins to behave not like planetary gravity, but almost like stellar gravity. And here's where things get truly strange. This outcast doesn't just drift through emptiness. It devours matter. 6 billion tons per second. Every single second. Where does so much matter come from in interstellar space, you might ask? Space is not the absolute vacuum we imagine it to be. Between stars float clouds of gas and dust, remnants of ancient explosions, the interstellar medium rarefied, almost imperceptible. But it's there. Hydrogen, helium, particles of heavy elements, cosmic dust, the size of viruses. An ordinary planet passes through this cloud almost without noticing it. But when you have gravity capable of rivaling a young star, everything changes. The rogue planet moves through the interstellar medium like a giant cosmic vacuum cleaner. Its gravitational field pulls in everything within a radius of millions of kilometers. Gas spirals inward, heats from friction, forms an accretion disk, exactly as happens around black holes. Only here there's no event horizon, no singularity. There's just monstrous mass that draws matter toward itself, layer by layer, atom by atom. 6 billion tons per second. That's more than the mass of all of Antarctica's icebergs melting into the ocean every second. Imagine a mountain the size of Everest disappearing in 10 seconds. That's the veracity of this cosmic wanderer. But where do rogue planets even come from? To understand this, we need to go back billions of years to the birth of star systems. When a star forms, a protoplanetary disk emerges around it, a rotating cloud of gas and dust. From this disk, planets gradually coalesce. First tiny pebbles, then rocks, then planetesimals, and finally full-fledged worlds. But this process is chaotic. Young planets collide, change orbits, influence each other gravitationally, and sometimes very rarely. But still one of them receives such a gravitational kick that it's ejected from the system forever. Imagine a billiard table the size of the solar system. The balls are planets, some Earth-sized, others Jupiter-sized. They roll along their orbits, but suddenly two giants pass too close to each other. Their gravity interacts, energy is redistributed, and one of them receives acceleration sufficient to overcome the star's pull. It breaks free from orbit and rushes into the darkness. Now it's a rogue planet, an orphan of the universe. A world without a sun, without light, without hope of return. Scientists believe there could be billions of such planets in the Milky Way. Perhaps there are even more of them than planets orbiting stars. We simply don't see them because they don't reflect light. They're cold, dark, invisible ghosts wandering in interstellar darkness. Some of them are Mars-sized, others Neptune-sized, and some, like today's protagonist, are so massive they balance on the edge between planet and failed star, a brown dwarf. But here's what's truly frightening. We don't know where they all are. A rogue planet could be a couple of light years away from us, and we wouldn't even know it. It doesn't emit, doesn't glow, doesn't send signals. The only way to detect it is to register gravitational microlensing. When an object passes in front of a distant star and its gravity bends the star's light, or wait until it passes close enough to begin affecting the orbits of our system's outer planets. And by that point, it might be too late. Now let's ask the question that keeps astrophysicists awake at night. What would happen if a rogue planet 10 times the size of Jupiter entered the solar system? The scenario seems fantastical, but mathematically, it's entirely possible. Space is vast, but time is infinite, and gravity knows no mercy. Such an object could approach from any direction, from above, below, from the side of the ecliptic plane, where we least expect it. And when it appears, everything will change. The outer planets would suffer first. Neptune and Uranus would feel gravitational perturbations long before the monster becomes visible in telescopes. Their orbits would begin to distort, becoming elliptical, unpredictable. Then it would be Saturn and Jupiter's turn. Two gas giants that for billions of years performed the role of gravitational shields for our system, deflecting comets and asteroids from the inner planets, would find themselves in a death dance with the intruder. Gravitational resonance could throw one of them into an elongated orbit, or even eject it from the system. Irony of fate, Jupiter itself could become a rogue planet. What about Earth? Even if the rogue planet doesn't approach us directly, its influence would be catastrophic. Gravitational perturbations would change our planet's orbit, we might move away from the sun, and then an ice age would begin that would make the last ice age look like a spring thaw. Or conversely, we'd move closer and the oceans would boil, the atmosphere would evaporate, Earth would turn into a second Venus. The third option, orbital eccentricity, would increase so much that we'd sweep sometimes too close to the sun, sometimes too far, experiencing extreme temperature fluctuations incompatible with life. But let's assume the worst scenario. The rogue planet passes within a few astronomical units of Earth. At such a distance, its gravity would begin tearing our planet apart. First, the oceans would suffer monstrous tides, hundreds of meters high, would crash onto continents. Then Earth's crust would begin cracking under tidal forces. Volcanoes would awaken simultaneously across the entire planet. Earthquakes of magnitude 9 and higher would become commonplace. The atmosphere would begin escaping into space, drawn by the giant's gravity. And ultimately, if the object came close enough, Earth could be captured by its gravitational field and become a satellite of the rogue planet, doomed to eternal darkness and the cold of interstellar space. Sounds like a Hollywood blockbuster scenario, doesn't it? But all the terrifying beauty of this picture is that the physics here is absolutely real. This isn't fiction, not fantasy. These are mathematically calculated consequences of two gravitational fields meeting. Scientists have modeled such scenarios on supercomputers, and the results are always the same: chaos, destruction, restructuring of the entire solar system's architecture. Does humanity have a chance of survival? Theoretically, yes, but practically, it depends on how early we detect the threat. If we had 100 years, we could attempt to evacuate part of the population to orbital stations or colonies on Mars. though even these shelters would be under attack. If 10 years we could only observe the approaching end, building underground bunkers in futile hope of weathering the cataclysm. If less than a year, all that would remain is to look at the night sky and wait for a new star to appear on the horizon. Except it wouldn't be a star. It would be the sun's reflection in the giant's atmosphere, the last glimpse of light before eternal darkness. But let's return to the planet discovered in 2025. 6 billion tons of matter per second? Where does all this mass go? Part of it settles on the planet's surface, increasing its size by microscopic portions. Part heats to such temperatures that it begins radiating in the infrared range. That's exactly how scientists discovered this object. The accretion disk around the rogue planet glows with a faint crimson light, invisible to the human eye, but discernible to sensitive infrared telescopes. This glow is a sign of colossal energy absorption, friction, and gravitational compression. What would a hypothetical observer feel if they found themselves near this object? Imagine you're on a spacecraft 1,000,000 kilometers from the rogue planet. Before you, absolute darkness, interrupted only by the faint glow of the disk. The planet is so black it absorbs all incident light like a black hole. You can't see its surface, can't distinguish clouds or continents, only a silhouette cut from the very fabric of space. And this silhouette grows. The planet's gravity pulls your ship toward it, and you realize the engines are powerless. You're falling, slowly but inexorably. Everything around accelerates gas particles, dust, debris from ancient comets. All of it rushes toward the giant's surface, forming hurricane winds of matter. Speed increases, temperature rises. The ship's hull begins to glow red hot. And the last thing you see before the instruments fail is vortices and whirlpools in the planet's atmosphere, each the size of Earth, each a grave for thousands of worlds. The history of the universe is full of such monsters. Rogue planets are a reminder that space doesn't forgive mistakes, knows no compassion, and pays no attention to our fears. They exist according to the laws of gravity and inertia, wandering in darkness for billions of years, not knowing and not caring what lies in their path. Some of them were once home to oceans and atmospheres, perhaps even to life. But when they were ejected from their home system, all of it froze, died, turned into an icy wasteland. If these worlds could tell their story, it would be the saddest story in the universe. A story of loss, loneliness, and endless wandering to nowhere. And yet, despite all the horror, there's something mesmerizing about rogue planets. They symbolize absolute freedom. No master star, no orbital constraints. Only an infinite journey through the galaxy, through star clusters, through voids between spiral arms. Such a planet could cross the Milky Way from edge to edge in hundreds of millions of years, become witness to the birth and death of thousands of stars, see things that no world with a fixed orbit would ever see. This is a cosmic wanderer in its purest form, an eternal pilgrim of darkness. Now you know that there, in the gaps between stars, in those empty spaces that seem like absolute nothingness to us, entire worlds are actually hiding. Worlds without light, without warmth, without hope of salvation. They rush through vacuum at unimaginable speed, devouring matter, warping space, remaining invisible until the last moment. And someday, perhaps in 1,000,000 years, or perhaps in 1,000, one of these planets might find itself too close to us. And then everything we know, everything we've built, our entire civilization will face a force before which we are as helpless as grains of sand before a hurricane. But until then, we can only look at the sky, study telescope data, build models, and hope that space will preserve its love of order a little longer. Because in a universe where rogue planets exist, that devour 6 billion tons of matter per second, our little pale blue dot is a miracle. Incredible luck, a fragile balance that we must cherish every day. Thank you for being with us on this journey to the boundaries of the possible and the unimaginable. If this video made you look at the night sky in a new way, give it a like and write in the comments what you think about rogue planets. Support our channel on Patreon so we can continue exploring the most amazing mysteries of the universe. Subscribe to our Telegram channel, where we share astronomy news and exclusive materials. Stay with us, and until our next meeting among the stars.